Question 5. Triangle ABC has been transformed in 3 different ways, resulting in triangle DEF, triangle GHI, and triangle JKL. Match each triangle in the left column with the single transformation that maps triangle ABC to that triangle. So we're wanting to know what transformation. It's a single transformation, so there's only one thing that's going to happen. It's either going to be a rotation, a translation, a reflection, a dilation. So it's going to be one of those options. And the way that I'm going to do this is I'm automatically going to eliminate dilation, because dilation means that the image became bigger or smaller. So if I look at triangle ABC and I first compare it to DEF, I'm going to just check one of the sides. B to C, since these are the last 2 letters in the triangle, I'm going to compare that side length to the last 2 in the side length that's represented by the last 2 letters in the other triangle's name. So side length BC corresponds to side length EF. So BC is 2 units long, so is EF. So it is not a dilation. That is how I eliminated dilation right from the get-go. So now the question is, what is it? So again, we're going to be matching corresponding points, and it has to do with the order in which these are labeled. So point A is going to correspond with point D. So I'm going to compare this A to this D because of their location in how they titled it. So that means B's corresponding point is going to be point E. So B to E, and C is going to correspond to F. So I'm going to be comparing C to F. And I'm just looking at this, and it looks like a rotation, because point A became tipped on its side to be point D, so it looks like a rotation counterclockwise 90 degrees. Now, how am I going to check that? I am going to rotate this point counterclockwise 90 degrees. Now, how am I going to do that? I am first going to mark my point here at the center because it's my reference point. I'm then going to create a square that goes straight up and straight over to this point A, because this gives me a 90-degree angle right here in this corner, and I know that if I were to take this square and tip it 90 degrees, so if I tipped it 90 degrees this way, this will now be along this axis, because these are separated by 90 degrees, and where it attaches to point A it's still going to attach right here. So if it is a rotation, then the lengths will be the same. So let's step through this. So I start at the center and I say, okay, this is going to go up 1, 2 units, because that's how high it is that's how high point A is. So, and it is going to go over 1, 2 units. So now this has to go, this L has to go 90 degrees counterclockwise in order to see if I am correct on a rotation. So I'm going to bring this side length down, so it's going to go over 2 and up 2. So up 1, 2. And it does land at point D. So far it's looking like So far it's looking like it is a rotation. Let's check the next 2 points. So we have point B. There isn't a height on this, and that's okay. So I start at my 0, 0, and I go to point B. That is over 1 unit. Now if I rotate this 90 degrees counterclockwise, it's going to end up being right here at point E. That checks out. And then last one to check is at point C. It is 3 units. Now if I take this line and rotate it 90 degrees, it's going to be up right here. So it is a rotation. It's a rotation counterclockwise by 90 degrees, and that's how I verify my rotations. So triangle GHI now, comparing to ABC. Is it, again, it's not a dilation because I'm going to compare corresponding side lengths. So side length BC is 2 units, so its corresponding side length would be HI. It is 2 units as well, so it's not a dilation. So then I'm asking myself, okay, what happened from point A to point G? And it looks like it picked it up since point G is still pointing at the top and point A is at the top. I'm not thinking it is a rotation or a reflection because this hasn't changed the way point A to its corresponding point G is located. It's still at the top of the triangle. So then I'm thinking, okay, well then I think it's a translation. So then I'm going to count over. It went 1, 2, 3. So it went back 3 and down 1, 2, 3. So back 3, down 3. So anytime you go left and go down, it's represented by negative in the math world. So now let's check from point B to its corresponding side. How do I know what, how do I know what point B's corresponding side point is? Well, B is located in the middle of triangle ABC's title. So its corresponding point is going to be located in the other triangle's title. So H is its corresponding point. So I'm going to go back 1, 2, 3, down 1, 2, 3 to check and see if that was what happened. It is back 3, down 3. So now point C's corresponding side, point is I. So 1, 2, 3, 1, 2, 3. So yes, it is a translation. All right, now triangle JKL. Since point A is the first one listed and point J is the first one listed, these two are corresponding points. So I'm comparing point A to point J. Since point J is now at the bottom of the triangle, that leads me to believe that it's either a rotation or a reflection. Since we already did a rotation, I'm going to check a reflection first. And my biggest inkling is it's going to be a reflection around this line right here. So point A, I'm going to go at a 90 degree from the line of reflection straight up to point A to see its distance. It's 1, 2, 3 up, so its reflection, if it's true, is going to be 3 in the opposite direction. So that was 3. C is corresponding point is L because they're the last ones listed in the title. So C is 1 unit directly away from the line of reflection. L is 1 unit directly away from the line of reflection. So yes, it is. And B is also 1 unit directly away from the line of reflection. K is also 1 unit directly away from the line of reflection. So it is a reflection. Hope that helps.